When you solve an equation, you make sure you do the inverse operation. So inverse operations are adding and subtracting our inverses, multiplying and dividing our inverses, squaring and square rooting our inverses. So in example 1, you want to make sure that we're trying to solve for z. So you want to get your z's on the same side and your constants on the other side. So what I'm going to do is I want to get rid of the positive 5z, so I'm going to subtract 5z. So what I do to one side, I have to do the other side. So I'm going to have 3z plus 12 equals negative 21. So I'm still trying to get rid of the z, or get z by itself, so I'm going to subtract 12 first. So I have 3z equals negative 33, and then I divide, because this is multiplication, I'm divide to get z by itself. So z equals negative 11. Now make sure when you're solving your equations that you check and you plug in negative 11. So you should plug in 8 times negative 11 plus 12 and see if it's equal to 5 times negative 11 minus 21. So in an equation, if the left-hand side equals the right-hand side when you're checking it, then it's a solution. Okay, the second one, I want to get my t's together. So I'm going to add 4t because this was a negative 4t. So I'm going to add 4t to each side. So I have 6t minus 3 equals 9. And then I add 3. So 6t equals 12. And I divide both sides by 6, so t equals 2. Again, you want to plug in 2 and see if it checks. So does 2 times 2 minus 3 equal 9 minus 4 times 2? So does 4 minus 3 equal 9 minus 8? Does 1 equal 1? Yes, it checks. So t equals 2 is a solution. Okay, next one. This one is going to involve distributing first. So I'm just going to distribute the 2y. So it's 2y minus 6, because 2 times 3 is 6, plus 6 equals 70. I want to simplify the left-hand side. So I'm going to combine my 6's, my negative 6 and my 6, which would cancel out. So I get 2y equals 70 and y equals 35. So again, you want to plug it back in and make sure it checks. And then the last one, there's more distributive property going on. So I'm going to distribute the 6. So 6t minus 12 equals 18 minus 4t. And then I'm going to distribute the negative 3 minus 12 minus 6t. So I'm going to simplify the right-hand side. So the right-hand side, I have a negative 4t and a negative 6t. So it's going to be 18 minus 12, which is 6. Negative 4t and negative 6t is negative 10t. And I still have this equals 6t minus 12. So you want to add, I'm going to add the 10t to get my t's together. So I'm going to have 16t minus 12 equals 6. And then add 12 to each side. So 16t equals 18. And then dividing by 16 gives me t equals 18/16. Well, this is a fraction, so I'm going to reduce it by dividing the top and the bottom by 2, so it's 9/8. Okay, and then you can check it. All right, solve for, so example 2, 3, and 4, and 5 are all about solving for variables when you have mostly variables. So you're still going to do the inverse operation. So example 2, solve for L. So what's going on with L, W, and H is that they're all multiplying. So the inverse operation is dividing. So I'm just going to divide both sides by W and H, because that will leave L by itself. So my answer will be L equals V divided by WH. Okay, example 2, I want to solve for L. So I have L plus W. So I want to get rid of the positive W. This operation is addition, so I'm going to subtract W from each side. So it's going to be z minus w equals L. Okay, example 3, solve for h. So to solve for h, I'm going to multiply both sides by 3. So I have 3v, because 1/3 and 3 would cancel out, equals bh. And then to solve for b, I'm going to divide both sides by b. So I'm going to get h is equal to 3 times v over capital B. Okay, in the second one, I want to solve for h again. So I have this a half. So it's a half times b times h. So to get rid of the half, you can divide by half, or you can multiply by 2. So because 2 and 1/2 are multiplicative inverses, when you multiply those, you get 1. So now you're left with 2a equals bh. And what I can do next is I can divide both sides by b. So my answer is going to be h equals 2a divided by b. Okay, solve for L. So L is being multiplied by 2. So I'm going to divide by 2 at the end, but first I have to get rid of the positive 2w. This is just plus 2w. So I'm going to subtract 2w from each side. So this will be p minus 2w equals 2L. So to solve for L, I'm going to divide both sides by 2. So I divide the whole thing by 2. So there's a couple different ways you can write this. You can write it as p minus 2w all over 2, or you can divide each term by 2. So this could be written as p over 2 minus 2w over 2. The 2w, these two will cancel out. So your other answer can be p divided by 2 minus w. And then to solve for L, you just need to get rid of b squared. B squared is just an expression, number divided by b squared. So L equals c divided by b squared. And then solve for x. So what do we have to do for solve for x? Well, in this case, x is being divided by a. So now at the end, I'm going to multiply by a, but first I have to get rid of this positive 1. So I'm going to subtract 1. So I get x over a equals 1. Now to solve for x, this is being divided. I'm going to multiply both sides by a. So x equals a is the answer. Now just to show you, I'm going to plug this back in, because you can plug these back in. So let's plug in x, which is a. So a divided by a plus 1, does that equal 2? So a divided by a is 1. So does 1 plus 1 equal 2? Yes. So x equals a as a solution. And then example 6, or the second one of this, I'm going to subtract z first. So I get x divided by a equals w minus z. And then I'm going to multiply both sides by a. But when you multiply both sides by a, you have to multiply the whole thing by a. So these two will cancel out. So this would be aw minus az, because both of those terms need to be multiplied by a.